Hello everybody. I'd like to solve a problem in kinematics, motion in one dimension. So let's begin. So I'm going to start by actually reading the problem. A car starts from rest and accelerates at a rate of 2 meters per second in a straight line until it reaches a speed of 20 meters per second. The car then slows down at a constant rate of 1 meter per second until it comes to a complete stop. So the first question A is, how much time did it take from start to stop? And B, how much distance did the car travel from start to stop? So I think the first thing we should do is draw a diagram. So let's draw a car. Of course, this is not going to be a very good looking car, but we need to just get the point across. And let's say it's going to drive on a straight line. Okay, that wasn't quite straight, but anyway. And let's label this as point A. Sometimes it's easy to break the problem up into different pieces. So it starts from rest, so its initial velocity VA is 0 meters per second. I suppose I'll put the units. And its acceleration is, I'll also put subscript A, is 2 meters per second. And it's going that way. At some point later, we can call it point B, the car now has a little bit of different information, that being its speed at point B, as it reaches a speed of 20 meters per second. So here velocity at point B is 20 meters per second. It begins to slow down. Now this is very important. It slows down at a constant rate of 1 meter per second. So that means the acceleration at B is negative because it's decelerating. So this is negative 1.0 meters per second. I'll draw an arrow just to show that the acceleration is that way. And then at the last point C, the car comes to rest. It stops, completely stops. And I don't think we need any more than that. It's just that the velocity at C is 0, and naturally the acceleration is also 0. So now that we've got this little picture, it might make solving the problem significantly easier. So let's do question A first. A asks for the time. How much time did it take? So let's first calculate how much time it took to get from point A to point B. So from A to B. Now we're dealing with constant. The acceleration between A and B is constant. So we can use the formula, the velocity at B is equal to the velocity at A plus the acceleration at A times t. But I would like to put subscript A and B under t, just to specify that we're dealing with the time it takes from A to B. And then after some algebraic manipulation, we just subtract VA from both sides and divide by A. By making time the subject of the formula, we have VB minus VA all over A. We're going to plug in the values there. So TAB is equal to, velocity at point B is 20 meters per second. At A it started from rest, so it's just 0. And the acceleration is 2 meters per second. So 20 divided by 2 is 10. And we see with the units the meters cancel. And we've got seconds to the minus 1 divided by seconds to the minus 2. So that's minus 1 minus minus 2, which is 1. So it's just seconds. So it takes 10 seconds to get from point A to point B. Now using exactly the same reasoning, we just do from point B to point C. So here the final velocity is the velocity at C. The initial velocity is the velocity at B. Plus constant acceleration between B and C. And in the same way I did AB, I'm going to write this as BC, just to say that this is the time from B to C. Making it the subject of the formula, we have BC minus VB all over AB. And then if we just plug in the values, The velocity at vc is 0 because it stops. At vb we wrote it above, it's 20 meters per second, and all divided by -1 meters per second. Remember, it's negative because it's decelerating here. So we've got -20 divided by -1, which is just +20. Meters cancel. Seconds to the -1 divided by seconds to the -2 is just seconds. So the total time, which I'll just write as t, is the time it takes from A to B plus the time it takes from B to C, which is 10 seconds plus 20 seconds, which is 30 seconds. And this is a reasonable answer. Time is measured in seconds. You know you're not completely wrong if at least you get the units right, but you would still be mostly wrong. So now let's look at B. B asks for the distance. So let me modify the picture a bit. Let's say this is on the x-axis. Let me draw the Cartesian plane there. We've got x and y. Y does not play a role in this problem, so we don't have to worry. And we make going to the right positive x direction. So let's call this xa, xb, and xc. So what we want is the distance from A to B and B to C. So again, from my equations of motion, the appropriate equation would be from A to B. Of course, oh, what happened there? Sorry about that. A to B. Take the velocity at B. Done it again, I don't know. Velocity at B squared is equal to the velocity of A squared plus 2A times the distance xb minus xa. So we want this value. We want the distance from A to xb. So if we make that the subject of the formula, we get xb minus xa is equal to, so if we subtract va squared on both sides and divide by 2a, we get vb squared minus va squared all over 2a. That's a. I can plug in the values here. So vb is 20 meters per second. Now of course this is squared, and va was starting from rest, so it's just 0. We divide by 2 times 2 meters per second. Let's continue expanding. So 20 squared is 400, and the units are also squared, so we end up with meters squared times seconds to the -2 minus 0, so this just stays the same. 2 times 2 is 4 meters per second to the -2. The seconds to the -2 cancel very nicely. Meters squared divided by meters, we just power goes down by 1. And 400 divided by 4 is 100. So let's take 100 meters. So the distance from point A to point B is 100 meters. So again, using the exact same logic, from B to C, we end up with the final velocity vc squared is equal to the initial velocity vb squared plus 2 times the acceleration at b multiplied by xc minus xb. Again, making the distance the subject of the formula, we have xc minus xb is equal to vc squared minus vb squared over 2ab. So let's be careful here. Vc squared is 0, so 0 squared is just 0, minus, so we did do the calculation here, it's 20 squared, which is 400 meters squared per second as well, and divided by 2 over, now remember here we had -1 meters per second. because this is when the car was slowing down. So now 2 times negative 1 is negative 2. So we've got negative 400. We've got negative 400 divided by negative 2. So this is positive 200. And in units again, we see the seconds to the minus 2 cancel quite nicely, and then the meters squared becomes meter. So the total distance, so I'll just say therefore x, or the total distance, was the distance from A to B plus the distance from B to C. And that was 100 meters plus 200 meters, which is ultimately 300 meters. And this answer is correct. Alright, there's some other problems we can do, but I think I'll do it in a different video. Alright, thank you.